The topic is number of binary trees for given set of nodes. It means if suppose some number of nodes are given, like 3 nodes are given, then using 3 nodes, how many different binary trees can be generated? We are going to learn that. We will learn about 2 type of nodes, that is unlabeled nodes and labeled nodes. Let us start with unlabeled node. This is an example of unlabeled nodes. These are empty nodes. Labeling is not there. Alphabets A, B, C or numbers 1, 2, 3. Nothing is written in that. So these are unlabeled nodes. So if 3 nodes are given, how many different binary trees can be generated? I will draw them and show here. This is one shape, first one. Second shape, that is root, left and its right. Third shape with 3 nodes. Now next will be a mirror image of this one. This is the fourth one. The next will be mirror image of this. There are 5 different trees. So if there are 3 nodes given, number of trees, if it is a function, then the value of this function is 5. So if there are 3 nodes, we can generate 5 different shaped binary trees. 5. 1, 2, 3, 4, 5. Next, if there are 4 nodes, then how many different shaped binary trees can be generated? So I'll take 4 nodes. Number of nodes are 4. These are 4 unlabeled nodes. I will draw different shaped binary trees here. So here I have generated few. Look at them. First one, second, third, fourth, fifth, sixth, 7. I have drawn 7. Then I can take the mirror images and I can draw 7 more. This is one shape. So this is left skewed. Then also I can have right skewed. Right? So for each I can have a mirror image. So 7 more I can draw. So I will complete that. Now I have all 14 trees. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 different shapes of binary trees. So it means if number of nodes are 4, then we can have 14 different shaped binary trees. So for 3 nodes, we got number of trees as 5, and for 4 nodes, we got the number of trees as 14. Then for 5 nodes, how many it will be? For 6 nodes, how many it will be? Shall I draw every time and check them? No. Just for observation, I have drawn them. To explain you what does it mean by number of trees, I have drawn them, right? Now, there must be some formula for this one. Yes, there is some formula. That formula is number of trees for given number of nodes are 2n Cn by n plus 1. This is a famous formula. The name of this formula is Catalan number. This is a known formula. 2n Cn by n plus 1. So if n nodes are given, then these many number of binary trees can be generated. So for 5, how many? Let me calculate. T5 will be 2 into 5 C5 by 5 plus 1. This is 10 C5 by 6. 10 C5 by 6. And this is 10 into 9 into 8 into 7 into 6 divided by 5 into 4 into 3 into 2 into 1. So whole thing divided by 6. Now let us divide this and get the answer. 6 gets cancelled. 5 2's 10 is gone. 4 2's 8 and 3 3's 9. So this is 3 into 2 into 7 is remaining here. So this is 42. So T5 is 42. So for any given number of nodes, you can find out how many different shaped binary trees can be generated. If at all you want to try out and see how those trees looks like, then you have to draw all of them. That may not be practical, so I have just shown for 3 nodes and 4 nodes. Now one more observation I have to do here. See, when 3 nodes are given, what could be the maximum height? Height starts from 0 onwards. So 0, 1, 2. So 0, 1, 2. So the maximum height possible is 2. This tree is of height 2 and 2, and this is not a 2, this is 1, 2, 2. So how many trees are there with maximum height? 1, 2, 3, 4. So the number of trees with maximum height are 4, so that is 2 square. This is for how many nodes? N equal to 3 nodes. Then what about n equal to 4 nodes? Number of trees with maximum height. Let us count them. 0, 1, 2, 3. Yes, this is maximum height because there are 4 nodes, so the height should be maximum 3. So 1, 2, 3, 4. This is not maximum. No, 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 no. Yes. 5, 6, 7, 8. So 8 trees are there with maximum height. So this is 2 cube. So for n equal to 5, how much it will be? You can guess now. 16. Yes, this is 2 power 4. So for any n, how many trees will be there? 2 power n minus 1. So we have learned how many different shaped binary trees can be generated for given number of nodes. So we don't have to generate the tree, we can use the formula. And one more observation we did, then how many binary trees are possible with maximum height? So that is 2 power n minus 1. Now next, let us generate one more formula for Catalan number. So I will write down few values of a Catalan number. Then from that, let us see how we can come up with one more formula for Catalan number. So first of all, I will take the table of values for Catalan number. See, if n is given, then Catalan number Tn, that we know the formula 2n Cn by n plus 1. See here, value of n, and this is the Catalan number. So I will take the values of n and write down the Catalan number values also. See, if it is 0, then if you put 0 in this formula, you get 1. Then if it is 1, then it is still 1. For 2, it is 2. For 3, we know the answer directly, just now we saw. Then for 4, it is 14. For 5, it is 42. So for 6, I will find out using a different method. I will not use this formula. So just watch this one. I want the answer for 6. So for that, I will multiply these values. 1 into 42 plus 1 into 14 plus 2 into 5 plus 5 into 2. See, it was 2 into 5. Now 5 into 2 plus 14 into 1 plus 42 into 1. This gives the answer for 6. So the result of this one is 132. Let us use the formula for value 6 and check whether our answer is correct or not. Let us verify. T6 is 2 into 6, 2n Cn, right? 2 into 6, C6 by 6 plus 1. So this is 12C6 by 7. This is the numerator, then the denominator will be 7. Let us cancel these. 7 gets cancelled. 6 2s 12 gets cancelled. 5 2s 10. 4 2s 8. 3 3s 9. Remaining is 11 into 2 into 3 into 2. So this is 11 into 2 3 6, 6 2s 12. So 11 into 12, 132. So yes, we got the correct answer. By substituting in this formula also we got the correct answer. So how I got this one? I multiplied this one with this one and this one with this one, then this two, then this two, then this two, then this two. So let us prepare a formula for that one. So this is T6. So this is T0 into 42 is T5. T5 plus T1 into T4, then T. So the T values we are multiplying, right? So T2 into T3, then T3 into T2, then T4 into T1, then T5 into T0. So these are the terms, and each term is a product of two values. So this can be written in general form. Tn is a summation of two values, T of something into T of something. So what is this? This is starting from 0, 1, 2, 3, 4 up to 5, and this is 5, 4, 3, 2, 1. So one side it is increasing, the other part is decreasing. So this is increasing, this is decreasing. So if I take I value starting from 1 to n, then I should say I minus 1, because I is 1 means first time it should be 0. And this is n minus I. So yes, we got the formula. So Catalan number Tn is 2n Cn by n plus 1, 2n Cn by n plus 1. This is one formula, and the other one is summation of I takes values from 1 to n, I minus 1 into T of n minus I. So the Catalan number can also be written like this. This is a combination formula and this is a recursive formula. So that's all about the formula, Catalan formula. We have got two formula. Now we have to learn about labeled nodes. So I will remove this, then I'll explain you about labeled nodes. Now let us see labeled nodes. Labeled node means these three nodes are there. Now you can see they are labeled, right? In the previously there were no labels here. They were blank. Now something is written in that. So labeling is done. So A, B, C are labels. Then if labeled nodes are there, then how many different binary trees can be generated? That's what we have to find out. So without label, already we know the answer. Without labels, there are 5. And the formula is 2n Cn by n plus 1. We already know the formula. This is the formula. And for 3 nodes, answer is 5. But no, these are labeled. So labeled means if I pick up just one tree, this tree if I pick up, then this is unlabeled. So if I try to label it, how many ways I can label it? 3 labels can be filled in how many ways? 3 factorial ways. Let us see. Just I will label this A, B, C. And one more labeling A, C, B. Same tree, shape is same, but the labels are changed. Permutation of label has changed. So I have different ways of filling A, B, C, A, C, B, B, A, C, B, C, A, C, A, B, C, B, A. So 1, 2, 3, 4, 5, 6. So yes, these are 6 means this is 3 factorial. So one shape can be filled in 3 factorial ways. Second shape again 3 factorial, 3 factorial, 3 factorial. So every shape in 3 factorial ways. So for 3 nodes 3 factorial, for n nodes n factorial. This is the formula. So for labeled nodes, formula is 2n Cn by n plus 1 into n factorial, because the filling of labels. So if you look at this formula and separate it into 2 parts, this part is for shapes and this part is for filling, permutation. In how many ways nodes can be filled. So this gives you how many different shapes we can get, 5 different shapes. Then n factorial gives one shape can be filled in how many ways, that is n factorial ways. So if the nodes are labeled, then this formula. So that's all, end of the topic. So we have learned number of nodes versus number of different shaped binary trees. So this discussion or this analysis is useful further in other topics.